In this nugget, we take a look at cracking Windows passwords. This is all too easy. One of the first things we'll take a look at, though, is kind of the overall nature and overview of Windows passwords and how they're devised. We also take a look at the hash methods. It all revolves around a hash representation of the password, and that's pretty much where most of the cracking takes place. We take a look at some cracking methods, most of which are technical, but a couple of which are not. And then we take a look also at actually how you get the hashes, because they're not really available just to the casual observer. Then we take a look at once you get the hashes, how you can actually do the cracking, and there's kind of a demo section in here in the middle. And then after that, we'll take a look at Kerberos, kind of an overall view of how the technology works, and then more specifically, how to crack even Kerberos passwords. Do you remember back in the old days we used to have this thing called privacy? I mean, people used to keep diaries, right? But nowadays they just post everything on Facebook and we get personal information about people that we wish we never knew. Or they tweet about it or something like that. I remember back in the old days when I was in high school, my sister used to have this diary and it had kind of a clasp on it with a space for a keyhole. And of course, she had the key. And she would write in her diary every night, and of course she had to unlock the diary with that key. Now, being a budding young hacker at the time, I decided one day while she hadn't come home from school yet that I was going to pick the lock on that diary. So I fashioned a paper clip and I was able to pick it open. And I kind of thumbed through it, but I didn't even read anything. I didn't really care that much. I just wanted to see if I could get the lock open. However, I realized that this was a golden opportunity because I left it open so that my sister could see that I had picked it. And when she came home, of course, she was furious. But from that day forward, she never won an argument with me. Because if we ever got into it, I would say, "I've read your diary, and you ought to be ashamed." And from that point forward, I never had to do dishes again the whole time I was in my teenage years there. I've never actually told her that I never read anything that was in it. Maybe I ought to say something, but she doesn't talk to me anymore. I'm not quite sure why. Anyway, that's what passwords are supposed to do, right? Passwords are supposed to protect things. It should protect private things. It should protect your logons. It should protect your documents, all sorts of things. However, they are all too easy to crack for Windows and for Linux. Here we're going to take a look really at Windows passwords. All right, let's take a look at the way Windows passwords work. First of all, they use hashed values. And what this means is it'll take the password, let's just say the password is, pass for something simple, and it sends it through a hash mathematical algorithm such as a message digest 5 or an MD5. There's lots of different ones of these. There's MD5, SHA-1, all different kinds of them. And out of the end of that, once it multiplies it, if you will, or sends it through the mathematical hash, it comes up with a unique value that's obfuscated. So it might be 5, 7, B, A, 9, something like that. And it goes on and on and on. And what happens with this is it's also one way, meaning that you can't take this obfuscated value, reverse it through the hash, and then come up with the password. That does not work. Okay. So it's, in other words, it's not like normal math that we would have in other implementations. So if you took the number 40, for example, and divided that by 5, what would you have? 8. Okay. You could do a similar mathematical function there as well, right? You could take 8 divided into 40, and you would get 5, right? So this is kind of reflexive. But hashes don't work that way. You can't just shove it back through in the opposite direction or something like that and come up with the same result. Now, these passwords are also stored in specific locations. So in the storage here on Windows Server 2003 and older, there's going to be a folder there called Windows Repair because there's a file there called the SAM, okay, the SAM file, and it contains all the passwords. Now, you can't really just double-click on it in Notepad or something like that. It's obfuscated and not that easy to open it up directly. However, if you can access it, you could copy it and use certain tools to be able to crack open the SAM, and from that point forward, you could then see the actual hashes of the passwords. You still don't see the passwords, though. What you see there is just the hash, and much of the rest of what we're going to be doing here, we'll be talking about how you can make guessing attempts at that hash to then determine what the password is. Now, on Windows machines, again, these are all for local passwords. So on your Windows XP machine, your 2000, 2003, Vista, whatever, they will have a SAM file there that has local account passwords in it. However, in Active Directory, of course, you know that this is a centralized authentication database that uses Active Directory domain controllers. It stores all of its credential information there in a file called ntds.dit. Okay, which stands for NT Directory Services Directory Information Tree, if you're wondering. Anyway, that again is a file you can't just crack open. And it's really pretty obfuscated. There's not really that many good hacking methods for directly accessing the ntds.dit. However, I will show you a tool that you can use to still crack Active Directory. Now let's take a look at some of these hash methods that are actually used for our passwords. The first one is the old version. This is crusty, going back to early NT days. This was LAN Manager or LANman. And what this would do is it would take two 7-character password values. So let's take a look at it this way. If I take a square, oh my gosh, that's not looking very good. Let's try that again. You can see clearly I'm not straight. Or that didn't come out right. I can't draw straight. Let me use a little Photoshop magic here and do a little better job here. Let's do that, and then this, and then this, and then this over here. Okay, so now I've got kind of a rectangle and a straight line down the middle. What happens with LANman is it divides passwords into two 7-character portions. Now, the logic for that was for performance initially and a couple other things, but the net result of it here now is that it's not very secure. Because the longer a password is, the more difficult it is to crack. You can use a number of different methods, such as dictionary attacks, brute force methods, or even just guessing. And we'll talk about some of those as we come up here. But the thing is, since we broke this up into two 7-bit pieces, we only have 7 characters maximum that we really have to deal with. We have to crack this side first, and then this side second if it's longer than 7 characters. Also, if it's 7 characters or less, there's a common value that appears over here on this side of things. Okay, and it's a hash that is always consistent. You'll see that when we look at hashed values a little bit later on. You can tell just by looking whether or not it's a 7-character or less password, or 7 characters, or actually more than 7-character password. And then we also have another thing here. This would be NT-LAN Manager. This increased security a little bit, so we didn't have just 2 separate 7-value pieces of this. Instead, it would go to, let me create another little box here. Instead, it would go to a 16-byte value. Okay, and that made it, of course, longer and more difficult to crack. Now, if you think about the days of LAN Manager and NT-LAN Manager, we didn't really have really strong processors back then. I mean, we were dealing with, what, 486 processors? Just a fraction of the power that we have now. So back in those days, they were still crackable using older tools like LoftCrack, which we don't really use a lot anymore, but because it's not used anymore like it was. But those tools could crack both of these. And to make matters worse, by the way, both LAN Manager and NT-LAN Manager passwords would be converted to all uppercase. Okay, so even if it was an alphanumeric or upper and lowercase password originally, when it came to cracking it, you only had to get all uppercase values in order to be able to actually use that password. Now, NT-LAN Manager version 2 expanded this to 128-bit passwords, and so, of course, this one's significantly stronger than those older methods that we had, still crackable, as is Kerberos. Now, I've said that Kerberos many times in the past is really pretty hardcore as far as a security mechanism goes, and it is a really good method. In terms of directly cracking Kerberos tickets themselves, that's really has not been successfully cracked consistently. However, there are still hash values that are used in Kerberos as well, and there are tools that can crack Kerberos. Now, the main methods that you can use for actually cracking passwords, first of all, are pretty non-technical. You could just guess. Sometimes if you know enough about a person, birth dates, the names of their kids, the names of their pets, that sort of thing, sometimes you can guess your way through it, especially if you also know something about the company's password policy, and you may have figured that out through other methods such as social engineering to determine what the complexity is and how difficult those passwords are. There's also shoulder surfing, and this is really simply where you look over someone's shoulder and watch what they type in. Now, I'm not very good at that. People, type the password in quick, and I can't really tell what order of keys that they pressed in. Some people are really good at it. Thankfully, however, if you have to actually shoulder surf over someone who's entering a password in on something like an iPhone, it's pretty easy because the actual characters show up in most password fields for a brief moment. It makes it a little bit easier that way. There's also sniffing. Now, there's a lot of different things you can do there. Sniffing means doing network captures, actually, using something like Wireshark, which we've used in the past in this series. And with that one, you can sniff either passwords in clear text. So, for example, POP3 will send clear text passwords when it authenticates against a mail server. Some versions of SNMP, what's another one? FTP, and a lot of other services and things or resources that a user might access will probably send their credentials in clear text. And even if it's not clear text and if it's a hash, well, you'll see here that we can also use hashes to crack passwords as well. Now, one of the things you can use once you've got the password hashes is a dictionary. This is where you would take a dictionary word, like, let's use the word apple. You can take that, and if you run it through a mathematical algorithm, it produces a unique mathematical result. We'll take a look at that a little bit more later on, but basically what we try to do is we take a dictionary of passwords, we compare it against a result and see if any of them match, and if they do, we know we've hit the password. We can also just do brute force, which is just really a pretty much computerized method for trying to guess every single possible combination of alphanumeric, upper, lowercase, and everything. And then there's also hybrid, and there's certain cracking utilities that can take both a dictionary attempt and a brute force and kind of combine both efforts at once, and that would be a hybrid method. So when it comes to actually the hashes and how we use password cracking and things to work that out, let's say that my hash, that is 123XYZ, and that's just my hash, okay? And then what I want to do is I want to try to guess a password. All right, let's say that I think that my password is going to be Coke, as in Coca-Cola, all right? And what I'm going to do is I'm going to take that word Coke, I'm going to run it through a password hash like an MD5, and I want to see what the hash result is. And maybe the hash result comes out as 789 ABC. Well, it's clear that Coke isn't the right password because when it came out of the hash, it's totally different than this hash up here. So now I know I got the password wrong. Let me try another one. Let's try Pepsi. Okay. Now when I run Pepsi through MD5, if I can write this, through my MD5 hash, maybe it gives me a hashed value of 123XYZ. Now I know I got it right. I hit the jackpot, and I guessed the password correctly. Now let me show you another example of all of that. I can use a little utility here called HashCalc. It's from Slavasoft. You can see this abundantly available from Google searches. But let's just say that here, once again, I would do a password. Let's say I think the password is Fuzzy Bunnies. Okay? I don't know where I come up with this stuff. Anyway, Fuzzy Bunnies. And here's a variety of different mathematical algorithms, in other words, hashes, that could be used. Windows uses MD5. I just click Calculate, and then I can see there that that's my hash. Okay, so I would just do that same comparison. I would compare that on the password with the hash that I generate and see if it comes up with a matched result in a hash table. Now you might be wondering, let me move this over. Where do we get these hashes from? How do I know what the hashes are on a Windows box? Well, those can be extracted and copied different places and so on. There's ways of grabbing that information, which I'll show you coming up here shortly. Let's try another one. Here's a hash that I got. Okay, I wonder what the password is for that hash. I'm just going to test my intelligence here. By the way, you might not know this, but I have an IQ that's just shocking. It's 73. So some of you didn't think it was quite that high. So anyway, let's say that my password was, Tom Magnum. Okay, Thomas Magnum. We can see that the password hash down here is nowhere near what the password is up there, so that's not right. Now let's give it one more try. I'm going to try maybe my 72nd IQ quotient here. And let's see if I do Phyllis, showing my age here, Diller. This is an old, literally old comedian from way back when. Again, password doesn't match. All right, one more time. I'm going to try Halle Berry. See what that does. Oh, what do you know? I must be a genius. Look at that. I guessed it on the third try. Yes, folks, that's how smart I am. Of course, I cheated because I typed that in advance and copied that into my clipboard and pasted it there into Notepad. But at least it makes the point here of knowing how these hashes are calculated. Now, I'm wondering, how do we get these hashes? Because I've talked about those a little bit, and they don't just appear from out of nowhere. You have to grab them somehow. If you have local access to the machine, one of the things you can do is to boot off of a live CD or USB flash drive. And there's a lot of different operating systems you could boot from, various flavors of Linux. Kali Linux, his own ISO, does have a live boot option, so you can use tools from that. Or you can log on locally and then, again, download or use tools from a USB flash drive or something like this, or a CD, and then you access it that way. I'll kind of show you both of those ways. Then once you have access to the machine locally, you can use pwdump. There's several versions of pwdump that you can use. Or you can use something like bkhive and samdump, and those are also included with the Kali Linux live CD. Remotely, you could do this over the network. A lot of different ways you can do this. Number one, you can use an exploit of some kind, for example, using Armitage or Metasploit, for example. And then once you get that, you can get a command prompt, or better yet, it's probably an interpreter. This is just a command line that you can access the local machine on. Once you do that, you can then copy tools to that local machine, such as these that I mentioned up here. And then what you can do is to get the hash. Once you get the hash, you'll have it in a file. And once again, you can use a variety of different file copy methods. You can use TFTP, FTP, whatever other method you want to copy the file to a location of your choice. And then what you would do is, once you've got the hash back to your machine using either the local or the remote method, then you would use cracking tools, which we'll come up upon shortly here. And then also, as a quick note, if you're using Active Directory or attacking Active Directory, you can use KerbCrack, and this will sniff Kerberos credentials, not directly, but it kind of sniffs the hash of them. It sniffs them over the network, and then it can use a cracking tool against those hashes, and then you can actually compromise Active Directory accounts. All right, now here you can see I've logged on to a Windows Server 2003 server, and we've got the administrator account here, of course. There's a help desk account which I created, and I also created James Bond, Pee Wee Herman, and the trainer account. Okay, now I want to start cracking passwords, but I might want to prioritize, especially in many environments where you might have dozens, hundreds, or even thousands of accounts to work against. It might be a waste of time to crack passwords that really don't have much power anyway in terms of the user account that's associated with them. So what I want to do is to make sure that I get to the administrator account, right? Now, what I'm doing here is I am going to show you a command prompt where I'm just going to show my who am I. What do I mean by that? Well, in Windows environments, you can type who am I /all, and it shows you everything about that account. So, for example, here I am, the trainer account, and the first part of this is kind of a unique value, or actually it's a common value, but in Windows environments, starting from the 5 down through here, it's going to be unique to this domain, okay? The first part of this just identifies it as a Microsoft product and so on. Really, this middle part, this series of numbers, this one and this one, is a unique number in the security identifier, or SID, that identifies a specific domain or a specific computer in this case. And then as you add accounts, they add up in numbers. The first account you create is 1,000, the second account is 1,001, and so on. And apparently there's been 16 accounts created on this machine, because I think this is the last one I created. Now, what I want to do with this is to specifically identify which account of all of these that we have here is the administrator account. Now, you might look at me and say, James, can't you read? The administrator account's right at the top. It says right here, built-in account for administering, and so on. All right. Well, just bear with me for a minute, okay? What I'm going to do is to mark this, and I'm going to start with the 5, and I'm going to work my way down to here. And the reason why I'm doing that is because I wanted to put that in the clipboard for use with this tool that I'm about to show you, and that is user2sid, okay? Another way I could have gotten that SID would be to do user2sid trainer, and it would show me that also, again, that same SID. Now, what I want to do this time, though, is SID to user. Now, this is a utility that was created by some student, I think he's a chemistry major, at the University of Moscow or something. It's been kind of an old tool, but it still works really well. And now what I want to do is to paste in the SID that I copied in earlier, at least this part of it, and I want to follow that with a 500. Now, this is a very important issue in terms of certified ethical hacker. The administrator account always ends in 500. Okay, so be aware of that and remember that. And it's also good and again useful for actual hacking as well. Now notice that what I'm also doing here, for some reason this tool does not like dashes, but it will let you put spaces in. In fact, it has to have a space where there's a dash. And it also doesn't care about the beginning of the SID, this S-1. It only wants us to start from 5. So now what I'm going to do is to type SID to user and then the unique identifier there and then the 500 at the end, and we'll see that our administrator's name is Pee-wee. Oh, for crying out loud. Did we just make Pee-wee Herman the administrator of our network? I don't know if you remember the show or not, but way back, I think it was in the 80s, there was the Pee-wee Herman show, and boy, wasn't that a whole lot of fun. Apparently now this guy's in charge of your network. So anyway, we now know which account, Pee-wee right here, is really the one that we want. He's not a hapless user. He's our administrator. Now, the next thing I would want to do here is from a command prompt. I've already copied some tools over here. One of those would be pwdump, and I'm working with version 7, but they're all good for what I'm about to show you. So I just do pwdump, and then I would specify that I want to put the dump into a, let's call it a w2k3 hash file, .txt, and I'll press enter, and we'll let it do its thing. And now if I do a notepad, w2k3 hash.txt, we'll see all of these hashes right here. Okay. Now, once again, let me change the format so this is a little bit more readable. There we go. Now, once again, we can see that Pee-wee is the 500. Okay. And then here is the hash of his account. This is a LAN manager hash. Okay. Or, an LM hash. And this is an NT LAN manager hash. The LM hash is going to be much easier to crack against. Also, before I get off of this notepad file, I do want to point something out. There's something interesting in these hashes that you should know about as a certified ethical hacker, especially if you're going to be a test taker. And that is that, remember I said that the password is divided up into two 7-character parts in LAN Manager. Well, this first hash here is a LAN Manager hash. The second part right here, if we look at it, AAD3B435 B51404EE. Any password that's 7 characters or less always ends in this. Okay, that's basically that part of the hash is saying this is blank, is what that says. Okay, so just bear that in mind. Now here I've gone to a utility called Kane. This is a great utility for a lot of different purposes. You can do brute force password attacking, dictionary attacks, and of course you can do different types of attacks as you can see here, cryptanalysis attacks. But what I need to do first is to add this to the list, and I can import hashes from the local file system, or I can import hashes from a file which I've already created. And here I've got my W2K3 hash file that I'm going to use. So I'm just going to go ahead and open that one and then click on Next. Now, here's all of the accounts that we saw earlier over on the Windows Server 2003 machine. Once again, here is our hashes. So let's just take an easy one here. Let's go to the help desk and let's just do a dictionary attack, and we could go LM hashes here. And we could click on Start. What happens here is it's going to use a default word list that exists here in the file location that you can see there. You can add additional words to that word list or choose different dictionaries if you want to. And then what we'll do here is just let it start going to work here. And you can see it's going through the dictionary at certain positions here. And we'll see what it comes up with. And look at this. It has got 2 of 2 hashes correct. The first hash, this is the blank one. Remember? That one was easy. It did that almost immediately. The second part of the hash, we find out now that the password is helper. Okay, and indeed our help desk password is helper. All right, now moving forward here, I'm going to show you another method to get the password hashes. I actually did all of this stuff I'm about to show you already, but I forgot to turn the microphone on, and so now here I am starting all over again. But anyway, what we've got here is I've booted a Windows Server 2012 R2 server. You're looking at that and saying, James, looks suspiciously like Kali Linux. Well, that's because I booted from the Kali Linux CD, or DVD actually. And of course, with that you can boot a live operating system. So indeed, that's what I've done here. And I have mounted the Windows file system here. So you can see I got a Windows directory, and it's very clearly, a Windows operating system. There's a System32 in here somewhere, which is something that we'll need here. So I could go into System32, and then there's config and so on. But I've already done that through the command line here. So you can see here, I've already mounted to that media, and it gives it kind of a unique identifier here, Windows System32 config. And if I do a directory or an ls here, we can see a lot of different files related to the SAM. In fact, there's the SAM file there. Now again, this is not easy to just double click on SAM or to use some kind of a text editor to crack it open. So what I have to do here is I use a tool here called bkhive, and then I go to the system and then root and then win12 hash. What I'm telling it to do is I want it to access the Windows Server 2012 system Hive and dump it all out into a win12 hash.txt file. Now that's not actually a readable file. Okay, so in fact, if I were to go down here, this is where it does all of that. If I were to go down here and go more and then root and then win12 hash.txt, it only shows me whatever that is. Looks like R2D2's in there or something, I don't know. So anyway, then what I do is I have to make this kind of human readable so that we can access the hashes. I do that using the samdump2 tool, and I tell it to access the sam /root win12 hash.txt. That's the original file. That's the one that kind of looks like a mess right here. I tell it to access that file, but to send it out to a human readable file called hashfile.txt. And now what I do here is, if I go further on down, now I can do a more to the hashfile.txt, and we can see human readable hashes. And from this point forward, I could just use these hashes in whatever tool I want to. I could use John the Ripper, which we haven't really addressed quite yet, but that's a good password cracking tool. I could use Cain, whatever else it is that I wanted to use. In reality also, if I do have physical access, I could probably create all of this in a batch file or a script of some type, and then just run it immediately. And really all I've got to wait for is the post to occur and for it to boot off of this. Then it'll run the script, and then I'm out of there. So then I could just reboot the server again so that no one gets suspicious, at least I hope. And I could get out of there with offline copies of these hashes that I can then crack against to my heart's delight. Now, since I was already in this boot, the live boot of Kali Linux, I decided to use utilities that are already here to crack these passwords. So I just went to the root and I confirmed that the files are there, and I just looked at the more of the hashfile.txt to make sure that I've got what I want. And then I'm running a utility called John. This is John the Ripper, and it's an excellent password cracking utility by brute force. The advantage of it is it doesn't give a fancy UI and progress bars and all that kind of stuff, so it uses all of its processing power towards cracking these passwords. And when we use a true cracker, if we're not using a dictionary, but a true cracker, what it's doing is it's going through every possibility of alphanumeric and upper lowercase and all that sort of stuff. It's just going through that all manually pretty much, and it takes a lot of processing power to do that. So here I'm running John against the hashfile.txt. I'm telling it it's using the NT-LAN Manager 2, so that's what NT2 is. And I'm specifying a user that I want to access, and that's the Tyler account. So it went ahead and ran this, and it took less than a second to do this, and it came up with the password blessed. That's the password for my Tyler account. Now here for the next account, I'm still running this one. It's under the Michael Scott or the M. Scott user account. It doesn't look like it's doing much. You might say, James, this isn't much of a tool. I mean, it's just kind of sitting there doing nothing. Well, remember what I said. It doesn't use any CPU cycles to show you progress or anything like that. But if you're really curious, you can press the space bar, and it will tell you what its current progress is. And we really haven't gotten very far yet right here. But if I just let this run and run and run, it'll eventually come up with a password. But it may take, depending on the complexity, days, weeks, or even months to come up with the appropriate password. Now let me return briefly here to our hash methods whiteboard that I was talking about before. Remember, down in this section right here, I was talking about the fact that we see password hashes, and we take a password guess, and we run it through an MD5 hash, and we see if it matches. And if it doesn't match, we know we got the password wrong, right? If it does match, then if it does go through the MD5 hash and it matches, then we know we got the password correct, right? So here's a computational quandary. It takes a lot of clock cycles to do this calculation through MD5 for every single password that your password cracker has to guess. Now, whatever the password hash winds up being, what we could do is we could pre-compute those. And what we do with that is, I'm getting kind of messy here, I know. But we could come up with a rainbow table, okay? And a rainbow table simply has hashes in it, okay, that correspond to various passwords. So all of the hashes that we could compute on our own, they've been pre-computed in a rainbow table, and it can be gigantic. It can be terabytes in size. I'm actually using that here. This is a tool called Offcrack, and you can see if I zoom in on it a little bit, Offcrack. This is the Windows version, which I've already downloaded, and I've already downloaded also a rainbow table that's, I think, 600 and some megabytes in size, but they have some that are upwards of 2 terabytes and larger. Okay. Now, what happens here is I just decided to go to my file, my W2K3 hash file, and here's all of my hashes for my various users. And I just took the help desk account again, and I put it in as a single load. And I do that by clicking up here, choosing single hash, and then you just enter in all the information as necessary. Here I'm going to paste it in, and I'll show you how I did it. I just pasted it from the Notepad document, and you can see here it's got all of the components in it. It's got the username colon, user ID, there's the user ID, the LAN manager hash, and the NT hash, and then that's pretty much it. So I entered all of that in, and I pre-computed all of this before I started recording again because it takes a little bit of time. And you can see here it took about 55 minutes to go through this gigantic rainbow table. That could still be significantly faster than doing just a brute force attack, however, against this same account. This Offcrack is growing increasingly popular. We used to use Cain and Abel a lot, and John the Ripper is still good, I guess. But this Offcrack, a lot of hackers are really, really liking this particular product right now. And let me show you something else here as well. Let me go back to my hash table. Let me show you this one. I have worked with a specific one of these. If I move over further to the left, that's my James Bond one. Now, since James Bond is supposed to be a spy and covert and all of that kind of stuff, I made his password pretty difficult. It's alphanumeric and upper lowercase, so it was a little bit more difficult and not quite as easy to crack. Well, you can also use this website right here. Let me show you this. Okay, if we zoom in on it, see objectivesecurity.ch. I really don't know how to pronounce that, but just make note of that where we are. This is the same website from which you can get Offcrack in the first place, right? So what I did was I went to this particular web page, and you can kind of test out their cracking abilities. I just pasted in this hash. Okay, that's my James Bond hash, and I clicked on go, and it gave me the password right here, and it gave it to me almost instantly. It's amazing how fast it was able to come up with that password. This could have taken days, possibly, using Cain or some of these other tools. So if you've got just a one-off, you might want to just go right here and just give that a shot instead of even running your own tools and consuming your own CPU cycles. All right, let's conclude here with a discussion of Kerberos, which was invented by MIT, or the Massachusetts Institute of Technology, and it's implemented in Active Directory by domain controllers. This will be a simplified discussion. There's a lot more steps than I show you here, but it suffices for our password discussion. Now what happens here is the client will ask for this will be my client, will ask the key distribution center or domain controller in Active Directory, my DC, for a ticket. It sends out that request. The domain controller will send back a ticket granting ticket. Okay? When it replies with a secret key in the ticket granting ticket that is hashed with the user's password. So, in other words, when we get this ticket granting ticket, it's going to be kind of mutually authenticated, and it could only have been issued by the domain controller because of certain cryptographic properties that are involved in it. So now when the client wants to access something else down here, like a file server, it needs a ticket granting session ticket. How does it get one? It presents its ticket granting ticket back to the domain controller and requests a ticket granting session ticket. Now, the domain controller knows that since only it could have created this TGT in the first place, that it's got to be valid, so it'll now send back a ticket granting session ticket, which can then be presented to the file server. The file server knows that only the domain controller could have created that ticket granting session ticket because, again, of the cryptographic properties involved in it, and it will then immediately trust it. So that's what our other steps are here. So that's kind of the quick overview of how Kerberos works. All right, now let's break apart Kerberos. Even though Kerberos on its own is a pretty secure implementation in terms of the cryptographic nature of it, it is still possible to crack it. You can do that using a tool called KerbCrack, and this is abundantly available through Google searches. But there's two parts, KerbSniff and KerbCrack. You use KerbSniff first. So I'm going to go ahead and run KerbSniff, and what you do with this is you send it out to a text file, which is going to contain the hashes. Then when you get asterisks in here, that's when you know that you've got some captured packets that you can use. And now, how do you get those captured packets? Well, you have to have some kind of a presentation of credentials. A good example of that would be, in this case, I've only got one machine left, I think, that's not a member of my domain. That's my Windows XP client over here. So I'm just going to join this to the domain. And when I do so, of course, it's going to prompt me for credentials. I was just getting ready to do that machine, and you might have noticed I just quickly switched over to a different XP box. The first one was not a legal copy of Windows XP, and so it barked at me when I tried to join it to the domain. I think this one's legal. We'll give it a try anyway. So I'm going to enter in my credentials, and we'll go ahead and join this computer to the domain. And it looks like it was successful, so I must have entered in the correct credentials. And then over here, I just got an asterisk. So if you don't see an asterisk, if you press space, see if it'll give you one. And if it does, then it picked up something. So then I controlled C to stop it. I accidentally tried to open up KerbSniff with Notepad, and that was a mistake. So anyway, now I open up Notepad to kerbsniff.txt, and there it is. Now I've got that hashed value. All right, now that we've got that kerbsniff.txt file, I'm going to run KerbCrack against that file, and I'm going to use a -d to point it to an unabridged dictionary that I just downloaded off of the internet. And I'll press enter here, and we can see that it didn't take very long for it to figure out that the password for this account is acupuncturator, whatever that is. I suppose that's somebody that practices acupuncture. But you can see how scary this is, though. I mean, because as secure as Kerberos is supposed to be, I've just sniffed the network, captured a hash, and now I'm able to run a password cracker against it, and it wasn't really very hard. In this nugget, we took a look at cracking Windows passwords with an overview of Windows passwords and how they're put together and how the hashes work out. And we also took a look at how the hash methods actually do their thing and how they're calculated. We took a look at cracking methods themselves, such as something simple such as shoulder surfing or just guessing, but also more technical methods such as dictionary and brute force and hybrid attacks. We also took a look at how to actually get the hashes. Remember, you can use something like a pwdump or samdump to be able to get the hashes from a Windows system. Then we took a look at how to actually crack those. There's kind of a demo here in the middle where we actually did some cracking. Then we took a look at Kerberos, again as an overview and then as a demo in how to actually crack Kerberos passwords. Well, I hope this has been informative for you, and I'd like to thank you for viewing.